start, welcome again to today's GeoMedia speaker series, the live edition and online edition. Join me also in welcoming Pablo Abend. He's our current visiting professor of Geomedia Studies here in Karlstad, and he's professor of design theory at Burg Giebichenstein University of Art and Design in Halle in Germany. And our speaker today is Bernard DIONYSIUS GEOGHEGAN. And I pass the microphone now to Pablo, and he will introduce the talk. So, welcome.
Yes, hello, thank you, Cornelia. Hello from me. Yeah, it's my pleasure to introduce Bernard to you. Bernard DIONYSIUS GEOGHEGAN, as I learned, is a media theorist and historian of technology, teaching currently in Gothenburg and London, and you are in Gothenburg, I think, Gothenburg right now.
Yes.
In 2012, he received a binational PhD degree from the Faculty of Media of the Bauhaus University of Weimar and the Screen Cultures Program of Northwestern University. And currently, you are a fellow of the Max Planck Institute in Berlin for the history of science. Yeah, your research interests include digital media, visual cultural studies, software studies, and an overarching theme of your research is how cultural sciences shape and are shaped by digital media. And the concern spans his writing in the mutual constitution of cybernetics and the human sciences, ethnicity and AI, and the role of the mid-century military vigilance in the development of multimedia interactivity. His attention to cultural factors and technical systems also figured in his work as a curator, notably for the Anthropocene and Technosphere project at the Haus der Kulturen der Welt in Berlin. And yeah, he has many publications, but I only want to mention his most recent one, Code from Information Theory to French Theory, that just came out in January at Duke University Press. So, and without much further ado, I want to yield the floor to Bernard and your talk. Bernard, welcome.
Thank you. It's a real honor to be here. Let's do that little initial get the slides up and running shuffle. Okay.
Maybe to bridge this, I can also mention that we're going to have your talk, and then I'm going to have a short response to it, and then I'm going to open up for discussion. Sorry. Okay.
So it's a real honor to be presenting here. I'm really grateful to be in conversation with Pablo again, and also to be in dialogue with other people who are working on geomedia. And particularly as I'm spending a lot of time in Gothenburg at the moment, it's great to be talking to colleagues that aren't so far away up in Karlstad. So in the 1950s and 1960s, a new type of computational image made its way from specialized laboratories in fields like science, industry, and government into slowly visual culture, popular culture, the arts, associated with instruments like the analog computer. It promoted a graphical culture that privileged points, vectors, ratios, and planes. Sometimes these elements of the new graphical culture adapted in real time as if to invisible but systematic laws for their transformation. So the visuals might flicker and rotate. They might assemble or decompose, but they didn't seem to be subject to the types of visual laws that one identified with, say, the film strip, except perhaps animation, or the printed page. These symphonies of points, vectors, ratios, and planes nonetheless rendered a very concrete picture of the world, such as one might find in diagrams produced for seafaring, surveying, astronomy, or, for example, aerial bombing runs. U.S. computational artist Ben F. Lepowski, and we see one of his works here on the left, described his 1950s and 1960s computational artworks as, quote, luminescent moving masses suspended in space, end quote. Graphical terms that evoked his own expertise as a cartographic draftsman for the U.S. military in World War II. Another major figure in the new interactive digital visual culture, Douglas Engelbart, claimed that, quote, radar offered a model of a virtual datascape, end quote, for his work in the 1960s and 1970s in developing what became a lot of the basic elements of multimedia interactivity in personal computing. So my favorite example, though, of this, let's see, spatial, cartographic, geotechnical backdrop to the new types of digital images may be the early computer game Space War, which we see an image from here on the right, which premiered at MIT Open House in 1962. The game was one of dozens of early computer games based on varieties of aerial and spatial combat. Thematically, many of the images of the new video games promoted figures of nautical or astronomical battle. So in the case of Space War, and we can see this here, small triangles represented spaceships, dots represented stars, and all were displayed on a so-called cathode ray vector monitor of the sort used in mid-century computerized aerial defense systems, right? So we have a couple of different types of geographical mapping here. We have the fact that this all appears on a radar screen, effectively, right? We have a mapping of space as the kind of heart of the game. But then there was a kind of other geomedial backdrop to this that is really the center of what I'm going to be talking about today. So Space War was a lightly updated animation of the United States' first major national system for global positioning, the American Ephemeris and Nautical Almanac, funded by the US Congress and developed in concert with the US Navy. Battles in Space War played out against a literal backdrop of an earlier program, Peter Sampson's so-called expensive planetarium program, which visualized stars in a sector of the night sky as described by the American Ephemeris. So established with the backing of the US Congress, the American Ephemeris, which is essentially a kind of nautical, an almanac for locating stars and the sun and the moon in the sky at particular times and locations. The American Ephemeris had consolidated the United States' status as a global scientific and maritime power since the mid-19th century. In the 20th century, Columbia University astronomer W.J. Eckert, working at Columbia University's observatory, would not only spearhead the adaptation of IBM machines to calculating the ephemeris, he would, in so doing, develop the types of techniques, for example, punch card programming, that spearheaded methods of computation used by the Manhattan Project and people like John von Neumann. Which is to say, MIT hackers did not find the stars per chance and make them part of an early video game. Rather, the clock-like regularity of the stars galvanized early work on computing and provided the outlines not only for early computerized radar, but also early computer games. So this arrival of the American Ephemeris, of that particular almanac of the sky, in the hands of MIT hackers exemplifies a peculiar ubiquity of, say, maritime space, techniques of maritime navigation that runs, I think, through a longer history of computational graphics. We're not just talking about computer graphics here, but computational graphics. So the sea didn't just seem to provide a topic for new forms of calculation and visualization in the 20th century. In a certain respect, it functioned as a kind of topos, a terrain, an expanse that entered into the systems of vision and computation that would come to fruition in 20th century computer graphics. The forces of the sea and the stars, the pull of the tides, the open expanse of the sea entered into a decisive manner into graphical cultures that took shape in the course of the 17th, 18th, 19th century, and finally became embodied, for example, in a game like Space War. In so doing, they articulate what, borrowing a term from Christian Metz, we could call a Scopic regime of computation. The Scopic regime characterized, as I mentioned, by points, vectors, and ratios and planes that is finally popularized by personal computing. This was, however, no generic mathematical manner of vision. This was not simply a picture of the world in terms of geometry. Much less clearly was it a kind of observer or scopic subject of the sort theorized by vision and film studies in the course of the 80s and 90s, it was to a certain extent, and this is the argument of my talk today, a manner of seeing that related to seafaring. The turn towards seeing and seafaring that I hope to do in this talk today aims to resolve a long-standing problem in media studies: how to historicize and characterize the peculiar characteristics of the digital image, which seem to set it so apart from other visual media such as portraiture, painting, documentary photography, narrative film, and so on. So at this point, I'm going to do a little kind of backdrop, setting the intervention in terms of media studies and visual culture studies. It's a little technical, a little specialized. I imagine you know some of this, but it's a way of trying to argue why I think, for example, maritime knowledge offers a new and decisive manner for looking at computer graphics. So in fields like media studies, to a certain extent in art history, at least since the 1990s, there was an interest in the supposed incommensurability of the world as seen by digital computing and more established modes of pictorial representation, such as you might find in photography, in film. So theorists as diverse as Friedrich Kittler, Jonathan Crary, and Anne Friedberg argue that there was a kind of irreconcilability between the algorithmic approach to computer graphics and a more figural logic that appeared in fields like painting, film, and photography of more classical media. So that was one set of debates around digital visual culture. Said it's a total rupture with existing and dominant modes of visualization because it's all mathematical and computed. Linked to that, there was a second line of analysis and argumentation, more or less building on that first line, where theorists such as Alexander Galloway, Shane Denson, came to argue that digital graphics are basically just zeros and ones. They're abstract calculation without any relationship to human optics. One manner, therefore, of explaining where does this form of visualization come from that seems to be so abstract, so mathematical, so graphical. One way of explaining its origins we saw in the works of thinkers like Friedberg, who I just mentioned, or art historian Margaret Pratchka, who turned to modern art and avant-garde arts to find modes of visualization that recall digital media. So layered informational infographic approaches to vision, such as you might find in the personal computer in the age of Microsoft Windows and Apple personal computers. So all of these claims about the peculiarity of digital visual culture, the attempt to find new sources, for example, in avant-garde and modern art, rested to a certain extent on this, other kind of very popular account of visual culture that took shape in the course of the 80s and 90s, about the notion of a Scopic regime of modernity. This notion that actually one of the things that characterized modern visual culture was the emphasis on an embodied subject, such as was reproduced or encoded by Renaissance perspective. Among other things, it was said that this new way of seeing wasn't just a technique of making pretty pictures, but it was a particular way of producing truth, of validating what it means to see. And what it meant to say was essentially vision as from an embodied individual subject, as a tendency, a more or less secular subject, because it was focused on a single individual rather than, say, a God's eye perspective. And it's also associated with a proliferation of visual modes that, for example, start taking place in stable settings that can be easily visualized by humans, whether it's be interior drawing rooms or landscapes. And so this interest in the Scopic regime that comes out of these 80s and 90s debates lays the foundation for a version of visual truth, visual authenticity that is embodied, that in some sense is associated with the human retina. And then it's on that basis you can get arguments in the course of the 20th, late 20th, early 21st century that says digital images are totally different. It doesn't rely on a simple Renaissance perspective. It doesn't rely on a human body. It's all actually mathematics. Now, in a very broad sense, I actually think the arguments that some of these theorists I've mentioned, Kittler, Virilio, Denson, Gabri, I think they're quite right when they describe what's radical and different about digital visual culture. So far as you have a certain kind of limited perspective for defining visual culture, right? When you define visual culture more or less in terms of 18th and 19th century popular and fine arts, in the wake of the rise of Renaissance perspective, in the wake of 19th century physiology that identifies vision with the retina, when that's your point of reference for what digital culture is, or what visual culture is, then of course the graphical culture of computing seems to operate according to a totally different logic, right? There is, however, I would say, and this is why I'm interested in Seafaring, there are other vibrant, lively technical cultures of visualization, particularly technical cultures of graphics, that exist more or less alongside the dominant mode of vision associated with Renaissance perspective and, you know, Jay or Metz's Scopic regimes. And in this respect, I'm interested in one thing in particular. So in this, hold on. In this classic debate around Scopic regimes of modernity and so on, there was this kind of footnote in the literature. It's articulated by Martin J, and it's also elaborated, who's drawing on the work of Svetlana Alpers, who says, well, actually, when we look at the rise of modern modes of seeing, there may be this dominance of Renaissance perspective that slowly takes shape in the course of the 1400s and the 1500s. But Svetlana Alpers says that what's strange is that seems to dominate in Southern Europe. She says that in Northern Europe, particularly in Dutch art and particularly the work of Johannes Vermeer, she says there's actually another kind of visual culture happening. Not only, for example, are the paintings of Johannes Vermeer not strictly organized according to a single perspective, not only are they not necessarily consistently framed, but they're characterized, among other things, by a proliferation of multiple visual modes, description, quantification that appears in the image. So here we see a famous picture of Vermeer's The Geographer, where on the background you see, for example, one sea chart. To the right of the would-be geographer in the picture, you see what rolled up appears to be another sea chart. You see a compass, you see writing on the wall, you see a globe. So you have, as it were, in this image, a multiplication of different types of visual modes. The painting itself is not clearly organized into Renaissance perspective, but also you see other ways of seeing the world that are, as it were, pushing themselves, impressing themselves in some way upon the visual sphere. And so Alpers sorts of suggests, and then Martin J picks this up, he says, actually, there seems to be some other ways of seeing that are at the kind of margins of modern visual culture. The fact that they choose that Dutch, early modern Dutch culture is a point of reference for this is highly decisive because, and this is a theme in recent years, people like Alan Sekula in the 90s, Bernhard Ziegert in the last 10 or 15 years, have emphasizes that what's highly characteristic of the golden age of Dutch art is that it's deeply marked by seafaring. It's marked by the opening up of global navigation, which has a whole variety of impacts on visual culture. On one hand, right, and this also sets it apart from Southern Europe. In the Netherlands, as a tendency, obviously a large, diverse region, different, and we're dealing with periods around, 1600s, 1700s. There's some variation. As a tendency, there was more play between, say, the fine arts and graphical cultures and cartography. One saw, and this is kind of attested in Vermeer, one saw cultures of maritime visuality, cultures of cartography, impress themselves not only upon visual culture, but in a very practical manner, for example, in groups like guilds, right? The same guild for painters, there was one single guild in which cartographers, draftsmen, and painters might belong in common, right? So the separation between these visual modes is not so clear. Let me pull up a quote. Ziegert, for example, likewise notes that Dutch seascapes of the period featured an open and often liberal exchange between maritime and military cartography and classical painting. So images of the sea start breaking from Renaissance perspective, these well-contained, tidy indoor spaces, and you start seeing unsettlingly open spaces populated by naval vessels adrift, sometimes aerial perspectives that are alien to human perspective, but are nonetheless evocative of cartography. Now, so far, this is really still just the backdrop of the talk, where I'm trying to make a case for how and why we might, for example, want to say there's something really interesting and specific about the prevalence of maritime cartography that seems to populate 20th century visual culture. In a sense, what I'm trying to say is that actually what someone like Martin J. described as these alternative Scopic regimes, and he points towards the golden age of Dutch painting, maybe they're not actually totally alternative, right? Actually, maybe there's other graphical cultures that are existing throughout modernity. They're actually quite robust. They're not marginal at all. Now, they've been sidelined by fields like visual culture studies or media studies that tended to define the visual arts in terms of a highly refined Renaissance perspective, more or less indexed to popular culture and the fine arts, to the neglect of other kind of thriving graphical cultures that actually, if we look at them, would create a kind of continuity, a new set of relationships for the peculiar features of 20th century digital visual culture that's based on computation, that's based on graphics, that's based on an interplay between, for example, numbers, letters, images, sites, and instruments, right? So my talk today is not trying to say actually computer graphics are born at sea in the 1600s or something. You know, it's not that at all, right? But what I am trying to say is, if we want to start understanding the history, the orientations, in a sense, what's so specifically concrete about digital graphics, we need to start having a more capacious and robust history of graphical cultures that don't, for example, situate computer graphics in terms of whether or not it's a rupture from photography, a rupture from classical cinema, but rather see how it's developing a repository, an ensemble of visual modes that, whether we're taking it from Vermeer or whether we're taking it from cultures of maritime navigation, provide a hallmark for a mode of seeing that is sort of proliferating today. So there is, I would say, I'll just say briefly in passing, there is kind of one theorist who's a point of reference for me in this, and this would be, hopefully this would be Harun Farokhi, right? So Harun Farokhi, in his, not only in his late films, but in his last lecture, which I think was in 2014, he looks at computer graphics and says, what's peculiar about computer graphics is they seem to be oriented towards navigation, right? So what he had in mind when he said computer graphics are oriented towards navigation, he was looking at, for example, first-person shooter games. Some of you probably know he himself was also exploring in his late films simulated environments. And he said, computer graphics seem to be about mapping a space, allowing one to kind of visualize it and intervene in it, move around in it, map around it. It's a kind of construction of rule-based worlds which one can negotiate. And I think this is a kind of better point of entry to understanding computer graphics than just talking about whether or not they are not like other kind of visual modes, right? This notion of navigability. And when one says something like navigability is what's defining about computer graphics, one starts getting entry points into a larger set of discussions about digital visual culture, right? So you have, for example, famously, an early conceptions of computing oriented towards cybernetics, a term Norbert Wiener borrows from an ancient Greek term for maritime navigation. Norbert Wiener says, basically, this new computational culture is going to be about your ability to be like a cybernetic steersman, someone who's navigating flows in order to manipulate and move through the world. Myself, coming from the United States in the 1990s, of course, some of our early discoveries of the World Wide Web were with something like Netscape Navigator, which again imagines interaction with the computer as a process of navigating a vast space, standing at the helm of something. And so I think these references to navigability in popular digital culture, and I think also Farokhi's intuition that says, actually, the way we can describe graphical cultures is in terms of navigable images. These are all kind of invitations to start looking at seafaring and maritime navigation as a way of understanding how digital visual culture works. Okay, that was a long introduction, but I hope it wasn't totally boring or obvious. Let me just make sure. Okay. So in the centuries before modern computer graphics, as we knew it took shape, there was, I would say, at sea, this forerunner of what I'm calling a Scopic regime of computation. right? A way of visualizing the world that's centered on computational orientation. It took shape very much around instruments, very much around computational instruments, but they didn't take shape around the computer. It took place around maritime instruments such as the astrolabe, the compass, the nautical chart, the sextant, the log, which were technologies that were not so much a series of one-off instruments for you do this or you do that to find your way at sea, but they were a network of technologies that worked together to create stable orientations at sea that could be calculated. So as European ships traveled further and further from European shores in the course of the 1400s, 1500s, eventually seeking to cross oceans, these instruments provided an invaluable protection against the many threats of being at sea, and they had a particular way of securing that protection. It was through computation. It was through computational methods that allowed one to translate on a regular basis between observations of the natural world, things witnessed through visual devices such as the sextant, and printed media, for example, such as almanacs. Now, key to this is they didn't simply just map the environment, right? They were not simply media of the physical world, of the environment. In a certain sense, these technologies, insofar as they took their orientations from observations of the sea, observations of the star, observations even of the magnetic pull of the earth, they incorporated the natural environment into a distributed system of visualization. So this new way of seeing transformed seafarers into what could be called a more than human perceptual system. So remarkable in this connection are the thoughts of the 19th century German text and geographer Ernst Kapp, who wrote, quote, "From the moment the pilot no longer merely has his hand on the rudder, but rather also simultaneously has his eye on the compass, from the moment that this has become an integral part of the body of the ship, something spiritual was inspired in the ship, as a result of which the human enters into community and a relationship with the vessel, which is so fully given him its power that the farthest lands of all the oceans come into contact," end quote, right? It's a long quote, but already in the 19th century, someone like Ernst Kapp can have this highly cybernetic description of what does it mean to use instruments at sea. It means a couple of things at once, okay? It takes individual perception and it plugs it not just into the instruments, but into a kind of natural world such that the sea itself becomes part of a planetary expanse, right? And this proliferation of all these instruments like the compass, the sextant, the almanac are this extraordinary multimedia amalgamation of visuals, of numbers, of charts, of tools, effectively aimed to producing the sea as a kind of stable, computable expanse. So now I want to start looking at the elements of this graphical visual culture that I see taking shape in early modern maritime navigation that I think lays out a scopic regime oriented towards points, vectors, ratios, and planes. So one of my real, what's the word for it? Guiding spirits for this line of analysis is the historian Margaret E in Canada, who's helped reconstruct the visual history of early modern sailing in her magisterial history sailing school. In frontispieces and instructional diagrams to navigation handbooks, many of which in the first instance center around Amsterdam, that context in which Alpers was interested, that she identified Dutch art. So in frontispieces and instructional diagrams, she uncovers a strange sort of hybrid visuality where instruments, mathematics, and experience intertwine, where the earth and the sea and the heavens are defined in terms of ratios that are elucidated through geometrical, logarithmic, and trigonometric analysis. So particularly in Amsterdam, you had a complex of medial, aesthetic, and economic affordances that came together with surprising speed in response to maritime navigation. So as navigation aligned with imperial schemes of planetary extraction, sailors incorporated more and better forms of astronomical and instrumental knowledge into visual technologies for planetary navigation. So to draw examples that we see here, we have a lunar Vovelle for calculating the age of the moon, that's there on the left, published in 1681 in a Dutch almanac for sailors in training, sometimes termed an analog computer, partly because of sturdier analog versions that would in metal hard code astronomical calculations into a series of complex interlocking wheels. Maritime vowels were, by contrast, a more or less simple affair of paper, possibly string and glue. On the right, we see a cynical quadrant shown here for offering a simplified solution to the sailor's triangle for calculating distance traveled at sea in the form of graphical plotting of points, vectors, and ratios, which there would be a little string at the bottom so that you could figure out what angle is the ship traveling, and based on what angle the ship is traveling, how far have you gone, which in turn wasn't just for making sure you reached your destination correctly, but so that you could have accurate, for example, lunar observations that would help you determine your location at sea. So across the 17th and 18th centuries, scientists and instrument makers across Europe made tremendous leaps forward with navigational tools, so that these and other instruments gradually became part of a visual environmental system that included, for example, astronomical tables, which combine observations of the place and motion of celestial bodies according to specific place and time of year, right? And so this is effectively what the ephemeris was. The ephemeris that served for space war. You had, of course, the compass, used to orient oneself not only to the land or the poles, but most crucially to the stars. The sextant, a highly sophisticated visual instrument for measuring the angle and distance between a celestial body and the horizon. The chronometer for keeping time so that ongoing observations would be correlated with the predictions of astronomical table. And there were, of course, a great deal of supplementary methods for correcting false observations of the star on the horizon, for recognizing the refraction of light. So here in this network of instruments that include paper, that include equations, that include tools bound to the sea and the land, the earth and the sky, emerges the first robust and, to my mind, totalizing Scopic regime of computation, a field in which matters of mathematical addressability, of the ability to computationally assign accurate points and derive accurate vectors, forms a total environment. Taken together, the tools of navigational computation form key elements in the formation of this Scopic regime, by which symbolic orders, technical codes, absence, and to a certain extent, political and economic structures work together in producing a robust visuality. So the erstwhile sailor Herman Melville's Moby Dick, first published in 1851, offers one particularly memorable account of this visual culture, of its multimedia interactive capacity, in chapter 44 of his book entitled The Chart. And one thing that's characteristic of this of the chapter there, where he describes a sea chart, there's a word for a map of the sea. It captures not just the graphical and epistemic power of the new types of maritime visuality, but also something like psychographic ambitions that underline them. It also talk about geoscopic ambitions. So the narrator accounts how when Ahab retired to his private quarters, he unpacked rolls of, quote, yellowish sea charts and spread them before him on a screwed down table to intently study the various lines and shadings which there met with his eye. And with slow but steady pencil trace, additional courses over spaces that before were blank. He would refer to piles of old logbooks behind him. Almost every night, some pencil marks were effaced and others were substituted. For with the charts of all four oceans before him, Ahab was threading a maze of currents and eddies, calculating the drifting of the sperm whale's food, and also calling to mind the regular ascertained seasons for hunting in particular latitudes. Here's a kind of map to help you visualize. So in this account of how it is that Ahab is trying to track, for example, there's one particular whale around the entire planet, you have this story of a planetary expanse where charts, logs, lines, points, and vectors come together to produce a navigable and controllable planetary environment. Data points assemble, cross-references proliferate, empirical observations and rational derivations interlace, all consolidating something like a graphical interface, right? And this is one of the things I would try to kind of emphasize. There are a couple of ways in which I see this as, I'm kind of at the risk of jumping to my conclusion now, but I feel like I should give some markers along the way. There's a couple of ways in which I see this as important repository for understanding outlines of 20th century digital visual culture, right? These are not pictures, right? They are literally interfaces, right? They're basically data interfaces meant to facilitate real-time intervention in the environment. The paper, of course, is not stable, right? It's meant, as we see with Ahab, it's meant to be updated, drawn on, modified. It has this mixture of visual elements, textual elements, numerical elements. This effectively relies on a certain amount of expertise. And of course, you're working alongside instruments such as the ephemeris, right, the nautical almanac, so that the picture you see works hand in hand with, for example, tables, charts, logbooks, data series, right? And that does not, for all that, mean this is not a way of saying, like, you know, part of what this talk is about is, in a way, is trying to understand how can we understand what's concrete about computer graphics, right? There is a certain tendency, and this is what I think was on display in thinkers like Galloway and Kittler and so on, to say there's something wildly abstract about this algorithmic approach to making sense of the visual sphere, right? And of course, if your point of reference is a Hollywood film from the 1930s, this is wildly abstract, right? But there are robust and rich visual cultures in which this kind of forging of an interoperability between pictures and numbers and instruments is completely standard, right? That is completely, and this rejection of a single individual perspective as truth, but rather to say the creation of systems of observation that are held together by an alternation between numbers and images are just part of a natural and totally sensible way of seeing the world. The place where you see that kind of vision, it's not just modern day computer graphics, but you see it in maritime exploration of 1700s, 1800s, early 1900s. Now, I'll just note in passing, so in a footnote to the passage I just mentioned from Melville, he singles out the real computational basis to his graphical regime in a sea chart of whale migratory patterns, shown here, that was produced by Lieutenant Maury of the National Observatory of Washington, D.C., drawing on sources including logs from whaling ships. Maury had produced a planetary visualization of whale sightings, color-coded according to species and times of the year. And Melville explained exactly how, in the course of Moby Dick, explains how this chart broke the world down into particular degrees and time periods and seasons to, in principle, allow for the most perfect calculation of where whales would appear. So this pathos and realism, both of the chart as it appeared in Moby Dick, but also its correspondence to this real sea chart that we see in the background here, hints at the strange planetary drift to the Scopic regime of computation. Its tendency towards rendering not only physical space, but also rendering observations, forms of life, human and otherwise, in a visual mode for numerical as well as economic calculation. With the aid of new systems of printing, record keeping, visual techniques for representation, institutions like the US Navy, the Scopic regime of computation offered, if not blueprints, at least visions of a certain kind of planetary governance. Not only dozens of men on a ship, but also inspectors like Melville, insurance adjusters in Hartford, Connecticut, a burgeoning energy industry in the northeastern United States, and of course the sperm whale itself, all fell within this regime of resources rendered, in a certain sense, interoperable, available with the aid of a Scopic regime of computation. And yet a great economic peril threatened this, or a great environmental peril threatened this system of visual order. The astronomical charts, particularly in the 18th and 19th century, were riddled with errors. The sources of these errors were varied, deriving sometimes from printing mistakes, other times from flaws in the work of human computers. While it was clear that the sight of the stars and the moons followed algorithmic laws that could in principle be read off by properly equipped humans, it was nonetheless the case that the ability to read those depended on accurate charts, which were not available because human computers were too irregular in their work. So in the 19th century, English mathematician Charles Babbage envisioned a new method of instrumental calculation to meet this challenge. His proposal, the difference engine, offered the first workable plan for a modern analog computer, generating excitement among scientists, industrialists, and statesmen across Europe and North America. So though Babbage's machine never came to fruition, it opened up a new technical space, a new medial technical space where successor organizations such as the Burroughs Corporation could help provide the promised maps. Enlisted by agents of the American ephemeris, soon observatories were issuing new and improved nautical almanacs supported by the Burroughs computer, which in turn led to the aforementioned innovations of Eckert in punch card computing and the work of von Neumann and others. So this is a kind of different history of understanding how does a particular scheme of graphical observation, graphical analysis seems to take shape across the long history of maritime navigation. That maritime navigation lays the foundation for a computation of the environment that's mixing kind of visual and mixing graphical and calculative modes. And in a sense that's not all determining, but is significant, has a continuous through line, not just into early computing, but into, for example, the use of something like the ephemeris in space war games. But just to kind of conclude the talk, what I want to go just a little further to say, actually, what we understand in modern computational graphics, right? And what Feroki says we should be looking for a certain kind of navigable image. I actually don't think they're born with digital computers as such. I think they are born in mechanical computers, in analog computers at sea in the early 20th century, right? And so for that example, I would draw one's attention to a particular invention in 1916, the Sperry fire control system. In the Sperry fire control system deployed at sea in the 1910s, you start seeing computer graphics in the sense of real-time graphical outputs, featuring the rapid amalgamation of multiple data streams for action, stamped by addressable, often geolocatable data organized into grids. So as writers like David Mindell and Thomas Hughes have shown, the fire control system developed by Sperry and its successors shifted the task of identifying, targeting, and firing on an enemy from one or two persons on a ship to a corresponding system of information distributed across the ship. So the fire control system would include in it, for example, small kind of monoscopes for tracking the enemy ship, small it would have small bells and other timing systems for listening to when ballistics were shot into the sea, where they landed, so you could calculate their distance. And across the ship, you'd have all these observation devices where humans would watch in real time, both the enemy ship or the ballistic shot into the ocean. They would record the data. It would be entered into a kind of electromechanical system that would be transmitted, be transmitted below deck to the control room, and then it would be visualized in real time in what we see here in a so-called battle tracer. And the battle tracer was effectively an analog computer that had something more or less akin to a pencil. And on that, it would indicate a couple of things at once. It would indicate the ship that one was on. It would indicate the enemy ship. And in principle, it would do that according to a set of coordinates on the basis of which officers below deck could, for example, predict and identify where to target the enemy. So out of this, you see a kind of system of integrating sights and sounds. It's also drawing on data on currents, right? So it's getting information from the sea on the drift of the ship. And it builds it all into a single data processing system, which nonetheless, right, this is the thing, sea battle, really any kind of modern warfare is almost impossible to visualize. It's happening too fast at too great distances, also with too many tremendous instruments and modern warfare to be conceived by any particular human brain. The only way to kind of get a stable vision of the sea, a stable vision of the battle environment, is through a system of abstract calculation. And that calculation in turn needs to be visualized in order to be something one can interact with in real time. You have no cathode ray tubes at sea in the 1910s. You obviously have no bitmaps and modern graphical devices. What you do have is you have analog computers that can draw in real time. And so out of that, you get this system You get a new way of ensuring a timely relay among humans and machines. And you get this analog computer that can plot the motion of a host and enemy ship in real time. And so the resulting graphics, though, and this is part of the thing, they're not a picture of the sea, right? And even if you look at the visualization on a nuclear sub nowadays, you don't necessarily, they could visualize pictures of the sea, but they don't. What they tend to visualize is points, lines, vectors, points, vectors, ratios, and planes that are grasped in terms of their potential for transformation through kind of decisive manipulation in real time. They're environmental images where the manner in which that environment is intelligible and it's concrete and it's actionable doesn't depend on a particular kind of narrow Renaissance perspective, but it involves a kind of systematized way of seeing that amalgamates multiple different forms of, let's say, detection rather than visualization, and displays them in a graphical culture on screen. And on that basis, I mean, I think it can kind of bring us back to a kind of new way of writing the history of digital visual culture, which has a few advantages. As I said, it offers some kind of concretization, exemplification of what Foroki was intuiting when he said graphical cultures are actually, digital graphical cultures are about navigation. It offers a much more promising set of ways of describing what is concrete about computer graphics than, for example, the radical rupture from human perspective, because in fact, there is no real tremendous rupture with 20th century digital visual culture, right? What you see is a kind of acceleration, intensification of a whole set of visual modes that actually by that time have centuries and centuries of development if you sort of know the right kind of technical cultures to look for them. And then finally, what you get is a different kind of history of what computational visuality is, of what the Scopic regime of computation is. To be sure, it has something to do with simulation. The battle tracer, for example, or even all of those maps being used in the 1700s and 1800s, even the map of Ahab, they are to a certain extent simulations of a real physical world, right? But they're not some flight from the actual physical world, right? They're a way of dealing with planetary space. They're a way of dealing with planetary environments that are too complex, that are too fast moving, that in cases when you're at sea, lack stable coordinates that might orient vision, and in fact, start needing to use graphics, computation, numbers, an amalgamation of human and machine observation in order to make the world around us concrete and visible, right? So in this sense, part of the argument of the talk is a concrete empirical historical approach towards computer graphics also, I think, has to be a concrete empirical approach towards something like the history of geomedia. Thank you.
Thank you very much. Thank you very much for your lecture. So now it's time for my response, I guess. Yes, so thank you again for this great lecture. A lot of food for thought. And I think it's not only in my head are a lot of questions. And I want to keep my response really short because I want to quickly open up the discussion for the others. So my response mainly serves the purpose to give you some time to come up with interesting questions, but also to share some thoughts of why this alternative history, as I may call it, is interesting for thinking about modern geomedia or contemporary geomedia. So let me begin. So in media studies, people like grand gestures, like rewriting history is certainly one of them. But it is only particularly impressive if it's done well and convincingly. In my opinion, Bernard succeeds in doing just that here in his talk, but also in other of his publications, even though he tried to play this down in the beginning of his talk. But I think he writes the history of modern computer graphics by presenting a quite compelling alternative narration in which the protagonists are little noticed technologies, which I really like, such as globes, nautical tables, and compasses and the like. So just to bring you back to the beginning of his talk, he started by asking about the peculiarity of the digital image and where does the modern computer graphics first take shape. And his answer is not in the computer-aided design of the 60s or Xerox PARC in the 70s, but rather he grounds computer graphics in the early 20th century seafaring. So he shows that the roots of our contemporary Scopic regime of computation, as he calls it, reaches back much further than to the early days of the personal computer. So with Scopic regimes of computation, he means, as far as I understand it, the way of transforming the world in points, vectors, ratios, with multiple data streams of addressable, often geolocatable data organized into grids and planes. It can be even traced back to early modern times when navigational technologies such as astrolabes, compasses, nautical charts, and sextants were used to expand European empires and colonize the world. So this Scopic regime developed to full bloom when the sovereignty over the maritime space had to be defended against other European states, for example. So in the words of Bernard, the result was a new way of seeing the world, a Scopic regime that not only visualized the threats of a maritime environment, but also incorporated that environment, the sea and the stars, the horizon and the currents, into a distributed system of visualization. So as Bernard described here also in his paper, I read beforehand, An Ecology of Operation. By the way, I highly recommend. This is also a good read. There is a kind of a military history of contemporary screen media, often overlooked, but nevertheless highly relevant. So for example, he finds the beginnings of multimedia in early computer-aided defense systems in this paper I just mentioned, like the semi-automatic ground environment SAGE, therefore tracing popular visuality back to the workplaces within the aerial defense systems of the United States, for example, during the Cold War era. And after the land grab of maritime space, the Cold War era, Bernard makes clear demanded an unprecedented extension of control of the airspace in this case, while also demanding constant attention to possible threats. So one solution were interactive computer screens developed by SAGE, for example. So his talk today is kind of, as I understood it, a kind of a prequel to this paper, this longer paper, going further back to the beginning of maritime warfare and seafaring in World War I, and even before that in the early modern age. So while I found this really kind of refreshing and also quite convincing to follow these alternative histories of screen media and optical media maybe in general, and kind of an alternative to narration to art history, usual art history, it might sound a bit techno-deterministic, as I would like to say, at least for me. So, but I only think at first glance only, because I think the unique aspect of this approach is the reconciliation of a technology-focused and an kind of an anthropological media history. Because I think Bernard does so by pointing out that these systems are and have always been distributed systems between humans, technological components, and the environment. For example, the setup of radar in the 40s, he describes as a psychic apparatus of electromechanical relays, in which, I quote here from the other paper, the human operator acted as an additional screen responsible for filtering out signal from noise, that is, for distinguishing the phantom-like blip of an approaching enemy from clouds, flocks of birds, irregular surfaces, and other obstructions that rendered the returning signal difficult to read, end of quote. So Bernard always highlights the crucial role screen media played in these systems, in these distributed systems, and pays close attention to the actants of the in-between that connected digital systems and the user sensory apparatus. By the way, I really love the notion of, in the other paper as well, that the ashtrays in the SAGE were also part of these distributed systems. So all these little components. So I think it is precisely this kind of ecological understanding of media that is highly relevant for geomedia studies. Another relevant point is the origin of geomedia in logistics, I think. His meticulous tracing of the development of distributed control and defense systems sheds light on the kind of military logistical origins of the contemporary digital screen media, with video games and social networks in particular as part of a broader attention economy that fully formed for you during the Cold War era, as I understood it. So I find all this very convincing, and it gives me a lot of food for thought. But also to open up the discussion, maybe I want to ask perhaps, or have a critical remark and a question, because I see kind of this gap between in the history that extends from kind of the immediate post-war period into the 90s. And I have asked myself, like, is there nothing like kind of worth mentioning here that has perhaps contributed to the development of the current state of screen media or geomedia, and perhaps could be told in the context of a different kind of a civilian media history or more civilian media history? And before I put in the question mark, I would like to explain a bit, because as Fred Turner and among others point out, like post-war cybernetics, for example, has a quite diverse history, like including kind of a spiritual branch that fused American technology with American counterculture, deliberately trying to free technology from the military industrial complex in a way. Or think of experiments by Stafford Bear in Allendez, Chile, constructing a kind of a distributed decision support system to aid the management of centrally planned socialist economy. Also the history of computer games, which can also be told as kind of this hacker story originating in the Tech Model Railroad Club of the MIT. So I was wondering, and this would be the question then, if it's possible to keep the premise of the origin of many of these innovations or of the aesthetic of screen media in the military complex, while also pointing out some moments of deviation. So I wanted to ask if you see this as kind of a parallel history of modern screen media, or do you see it as part of the kind of the history you are bringing forward? So that was kind of a long question, but here's the question mark.
No, it's a really great question. Thank you for that generous and really penetrating summary. Okay, so this is like just a very frank answer. Okay, I want the answer to be to move towards a world of heterogeneity and exceptions that you describe, and every time I try to write it, I don't get there. So I'll just take an example, right? So this is part of it. As this is part of this book I'm writing. I write about maritime navigation. I write about radar, and towards the end of it, I write about, for example, Earth system sciences, GPS, satellite remote sensing, technologies like that. Partly because, like, and so I think I don't want a strictly militaristic history because I'm not totally convinced by that. However, there's a couple of things that make this complicated. Okay, obviously, whether you're writing about like colonial exploration of the world in the 1500s, 1600s, 1700s, you may not necessarily, these ships you're talking about, quite often they're not literal military ships, right? But what you start seeing is that actually it's a different form of violent extraction, right? And I would say violent force, particularly in colonialism and imperialism, that is not necessarily identical with the kinds of militaries that people like Kittler and Virilio talked about, but are actually a similar violent force. If one's talking about the proliferation of satellites and Earth system sciences in the lab, I mean, one has some very similar dynamics. Obviously, U.S. space satellites they're presented as scientific instruments, but that's not all they are. But nonetheless, I am really happy to be talking in a context dealing with geomedia, right? Because, okay, I'm totally excited and interested by people like Fred Turner and Eden Medina, who are doing what you describe, who are trying to find sources of, hippies and socialists that are using computation in a way that's not just strictly militaristic. But I also think this idea, and what I tried to do a number of times in this talk today, this idea of saying actually the environment itself figures in these technologies as agents in them and that shapes them. I do kind of see in there in geomedia a possibility of finding agency that doesn't just fit the simple schema of anthropocentric militarism. Nonetheless, every time I tell my stories, every time I write a chapter about this, on some level, it does seem like the schemas that draw all these media together usually seem to be at the very least highly strategic, and they're not, and highly violent, if not militaristic. So I think I would be really interested in adding geomedia as a kind of alternate heterogeneous agent to these systems that goes alongside Fred Turner's hippies or Eden Medina's, socialists in Chile. But I have not succeeded, try as I might, to find a way that something holds these together that's not human violence, unfortunately. But I'm really eager if people can give me tips on how to do that, because I don't want to keep telling the same old story of the military dominating everything, but it's what it sometimes feels like.
Hey, yeah, I'm not sure if we can convince you today or if I can come up with like this solution for this now.
Yeah.
Yes. Yeah, thank you for this answer. It's quite, I mean, I can kind of figure why one always ends up there. I mean, at least because, even Turner's story, I mean, he describes like kind of cybernetics originating in the universities. A lot of money came from the military sector, and that's the sector that puts in the money for this. But then also he describes kind of like the Bauhaus people came to the US and brought in their kind of more aesthetics from art experiments and stuff like that to the United States. So it kind of mixes in his history. But
and I think there's a lot to be said. Like what I've been trying to write about lately, and I'm not totally persuaded by it, but I'm working on it. So Fred Turner and Eden Medina, for example, just to pick the names that you cited, they point towards all these people who use and develop computational media in ways that are not entirely faithful to their origins. So like I've been writing recently about various video artists, for example. You could think of anyone from like famously Nam June Paik to this contemporary Canadian artist John Rathman, who have all these ways of trying to use computational media to imagine a different type of world, a different type of worlding, a different type of planetary relation. In the case of someone like Nam June Paik, it has a kind of utopic dimension. So I'm very kind of, and I think you can say in a fair way that like, okay, its scheme of the planetary would not exist without modern military violence, right? But the worlds themselves can't be simply reduced to Cold War cybernetics or something like that. And everyone is always, I mean, in a weird way, like, I mean, right now with like, I totally believe that when you have like a talk like this, where some of us are in different places, but we're getting together, we're exchanging ideas. Like, I think we're using some very related technologies, but I think we can build worlds that are not reducible to, colonial maritime exploration, right?
So it's also, I mean, it's not, you don't have to write every history. So it's probably, there is a history of appropriating these technologies, maybe.
Yeah.
Others also, I mean, have written about them. Okay, thank you. So I would actually like to open up the floor. I have a couple more questions, but maybe someone else. Maybe people need a little more time. So I was wondering, maybe one more thing. I was wondering why you never use the term, and it's a stupid question, basically, why not using term XY, but it just came to my mind, the kind of, because you also mentioned Farocki, and I don't think, and he talks about the operational image. So is that a concept that kind of works for you?
It does work. So
because that's also the kind of an alternative to art, basically, or something. So
I've been thinking about this also because UC Parika has this new book on operational images. And I think part of what UC achieves, right, as what UC achieves by leveraging Farocki's idea of the operational image is, in a way, like, I find it a really successful, the notion of the operational image is a really successful, compelling manner of getting around a lot of these thorny questions of subjects, of vision, Scopic, this, that, and the other thing, because immediately it's not whether or not you're before or after a particular human perspective, but it's a form of visualization that's systematized and distributed from the beginning. partly because my work on radar is so interested in operators.
Mm.
As I talk about maritime computer graphics, I'm trying to not immediately slip into the same language of operating and operational.
Mm-hmm.
And I'm, because it's the problem. The problem with Feroki's concept is that it's so powerful and convincing and generalizable. I'm completely envious of the concept. I'm envious of what UC Parika has done with it, but I'm trying to admire it and work with it cautiously and slowly, and not prematurely incorporate it into, say, like I feel very comfortable talking about 18th century maritime navigation as computation. I'm not, but I think calling it operations runs the risk of submitting it to a set of 20th century logistics that's not quite there yet. That's my instinct.
Mm-hmm.
It has the potential of being anachronistic. But it may be that in the course of finishing this book, I just realized Feroki had it all along, and I should just take the term into the body of the work.
Okay, thanks. Other questions?
One just like jump in, or do you want hand raising? Or
Since you're already on, I mean, I keep a list now, and you jump in first, and then Lars Lundgren and John Lynch I have on the list. Thank you.
Okay, thank you for your talk. It was very interesting. I'm always happy to see whale maps, so thank you for that, especially. And I'm not sure if I have a question or more of a reflection, but we can see where I go with this. But I'm also struck by how navigation and mapping is developed in relation to resources, of course, and markets, and colonialism and war as a way to keep those markets and grow them. So I'm interested in resources because you describe whales, which are a moving resource, but of course there are like placed resources where you rather keep war to move the borders around resource. Yes. But I'm interested in what happens when a resource goes away. Like, can you find discursively whales layered into the technologies? Mm-hmm. If you kind of get what I'm, this is a romantic notion on my part, that whale tracking technology would still be somehow related to what we do today. But I got very interested since you took this whale example, which was like this massive market of resources, and that is now, of course, not at all the same time. But yeah, I'm a bit interested in how like these technologies develop very much in relations to specific resources and markets that might entirely go away.
I think that's a really great question. So I have three partial answers, none of which are a full answer. Partially because it's a good question. You know what I mean? Take a little while to figure out. Okay. So one of the things I've been trying to sort out, and I don't do it in this talk because I don't want to sound too esoteric. So I'm really interested in the idea of like what it means that computer graphics render. Do you know what I mean? Like computational graphics are a way of rendering the world. And this what a colleague pointed out to me is like, oh, well, actually rendering is all what whales are about. Like all the whaling industry is about rendering whale fat, right? And like I haven't quite sorted it out, but part of the thing I am trying to figure out is an understanding of computational graphics in terms of what they produce, what they make available, that again doesn't just deal with this unreal simulation, but a kind of exchangeability on the screen and exchangeability in the physical world. So I'm just really excited that this also sounds kind of interesting to you. And that's the way I'm trying to get at it. I haven't quite gotten there yet. here's just here's what I wonder, because I now I'm going to chase this down and see if I can find what you said. I would have, so what's in the US, the center of the whaling industry is particularly the northeastern United States, right? Places like Canada, Massachusetts, New York. Okay, I mean, not Canada, New York, Connecticut, Massachusetts. And that's also like, it's also, you know, where you have for example, places like MIT, right? The best, greatest, earliest kind of scientific research institutions happen in the same region. And you know, it is said that like the whaling industry figured majorly in the economic development of the northeastern United States. So I would have to wonder if it's not a coincidence that MIT comes out of that same region of the world, because there's a particular type of technological mobilization that has something to do with like rendering the world, making it accessible, making it exchangeable, right? The other thing I wonder about is I've heard one or two talks recently. So there are people who are writing on how, for example, petroleum exploration figures as a major engine in new forms of computation. And this includes like visualization and detection of resources, for example, like in the Gulf of Mexico as far back as like the 1960s and stuff, right? And I just mentioned that because, actually, one of the major funders of cybernetics, the Macy Foundation, was it was from an oil company that was bought out by the Rockefellers, the Macy family. So I wonder if maybe this absence is felt partly by how one energy resource, the oil of the whale, becomes key in a particular type of graphical, technical, scientific innovation, or innovation is making it sound nicer than it is. And then maybe that place is taken over by another energy resource, petroleum, right? I don't know. And it's the same way, like, can one say the the whaling industry drives the Northeast as one sort of center of scientific, technical, and economic innovation that then is ripe for new places like MIT popping up? I don't know. But maybe, like, I'd be really excited if that could work that way, you know? Maybe there's a series of things, there's a chain of agents or catalysts that would have to include something like natural resources that stand in to make this new technical regime hold together. I'm going to think more about it.
Thank you.
Yeah, thank you. Just a quick answer to that also, when talking about Scopic regimes and everything, that when you're switching your target from this like moving animal that you are chasing to get the oil from like getting it from the earth, like having your very still resource, that switches kind of us from hunters to more of this vampiric consumer. Something about the outlook of the hunt and the outlook of like just draining the earth. Yeah, I'm gonna give space to other people, but thank you for your answer.
Thank you.
This is interesting. So there might be a new Scopic regime coming up for the post-fossil future. We're hopefully entering soon. A distributed one. So Lars Lundgren is next on my list.
Yes, hi. I'm Lars Lundgren from Södertörn University in Stockholm. Thank you so much for this super rich talk. I'm a bit curious about sort of the relation between territory and the sea, or territories and the sea, or the ocean, and sort of maps and territories and nautical charts, maritime navigation and the ocean. And this comes from towards the very end, you were saying, and I agree totally, of course, that sea charts or nautical charts, they're not pictures of the sea, they're visualized points and vectors and so on. And it made me think of Bill Rankin's book on After the Map, where he writes about GPS. And he's primarily drawing or building his account based on territorial maps. And he speaks of geoepistemology and territory and such things. And he speaks very little about sea charts and nautical charts and the sea. And I think somewhere Sigurd say that, okay, yeah, it's a big mistake to not speak about the ocean when you speak about maps. But one of the arguments that Rankin makes is that GPS, that it's non-representational, that it's about points and vectors and things like that. Whereas maps before the GPS were representational. So basically, that's a very different argument than you're putting forward here, where you basically say that, okay, maritime navigation has always been computational, or for a very long time been computational, and drawing different instruments together. And I'm thinking if that's having to do with the differences between sort of the elements, the territory as something which is made into a representation in maps because it's available and you have this Scopic regime or whatever you want to call it. But it's something very different with the sea, which is sort of usually thought of as a flat space, which is hard to navigate. And so I was curious to think about, okay, or for you to think about what is the relation between territories and the sea, and that's why maritime navigation makes such a good case here, and that you can't really transform this into something about territorial maps.
Yeah. So that's really interesting and helpful. So you've actually discerned part of the conceptual arc of the project, right? And so the part of the, I really think points, vectors, ratios, and planes are a good set of terms for for grasping what holds together a whole regime of computational graphics, both involving digital computers and not. So that's why I'm using those to define the Scopic regime of computation. But I'm also using it because I was really taken with Rankin in that last chapter of the book, talks about GPS being an epistemology of the point, or kind of pointillistic cartography, right? And I was trying to, as I was trying to figure out how can I connect this longer history of computational devices to, for example, contemporary mobile media, I was thinking a lot about, okay, what does it mean that for example, our photographs are so often geotagged, that we're so often using our mobile devices for navigation, and Rankin's argument that systems, not just GPS but also geographic information systems, are pointillistic. I was like, okay, this is a way that I can start constructing these continuities that I want between, say, multiple graphic cultures, right? Because this is partially a response to the last question. In a way, I'm trying to tell a certain type of technical history that's not necessarily about technology A begets technology B begets technology C, so much as a distributed system of, say, dynamics. And so I can't trace a straight through line of invention where one thing leads to the next, but I can say points, vectors, ratios, and so forth, start reconnecting. So this is just a long way of saying you read my mind, you figured out what my project was doing, and you figured out where it came from. Good job. you decrypted what I'm trying to do. And I think, and the other thing is just to say, basically, I think you're right, because I'm drawing here partly from the historian of technology, David Mindell, who's also written a lot about seafaring and the Sperry system. The bottom line is, like, navigation at sea, particularly at great distances, has to be wildly pointillistic, with or without GPS. There are no stable points of references. There are horizons, there are stars, there are currents, right? This is why Ahab's chart at all these lines and flows and sites of observation, like, that's not an abstract, it just happens to be the concrete vision of the world is points and lines and vectors. So I think you're probably right that the sea has a particular forerunner, a particular salience for producing this kind of spatial logic that Rankin sees coming to fruition in GPS. The one thing I would say, and this isn't very interesting, I think you're right. I think there's probably a distinction there between landed territory and sea territory. I'd have to look at Rankin again. I somehow think, though, I don't think there's a contradiction here. I think there's some way, it's the type of thing where I feel like one could probably sit down with Rankin over a beer and talk about these different genealogies of cartographic logic. And he would probably be able to be like, oh, yeah, actually, the sea is a forerunner for this and that reason. You know what I mean? I feel like you can accommodate it rather than having strict competing genealogies or origins. But yeah. The one thing I would say, though, this is also just a way of saying, this is why I think environmental history and a concept like geomedia can be so useful here, because it's actually, environments matter. The physical world surrounding us matters, and out of it comes different kind of technical and scientific logics. And so I do think turning the story, as someone like Ziegert also says, once you turn to the sea, you get a different set of questions and problems than when you're, charting land.
Yeah, thanks.
Okay, John Lynch, I have on my list next.
Thank you for the presentation. It's great to see the images that you used. So I just wondered if you could say a bit more about the sort of idea or how you define this in terms of aesthetics, really. You're using a lot of kind of art history terms. You're even talking about pointillism and things like this, Vermeer and perspective in painting. And with something like, say, the Vermeer picture, and thinking back, many years to sort of when I studied art history, I mean, what you have is something like that is some kind of mapping of perspectival space, that kind of abstraction. But then, the second half of the lecture was the subjects of the painting, the who was represented, the kind of ideological translation from the geometry to the representation we have. And it was also interesting that you talked about Moby Dick, where you said, which again is kind of a literary aestheticization of those charts. So there seems to be this kind of operation that takes place into an aesthetic realm, which so I just wondered if you could say something about it, because in one sense, again, the way that we were directed to think about that was in terms of what kind of subjectivity is produced, what kind of subject is produced in relation to this, and the novel would work in that way. And just as a final thing, it just reminded me a little, in that context, it reminds me a bit of sort of Weismann's notion of investigative aesthetics, where there's a use of those the data and those visualizations for a very resistant and contestable form of aesthetic practice. So I just wonder if you can say just a little bit about that.
Yes. So there's a couple, so this is all really helpful to me. A couple of points. I think it's true, it's in a weird way, in some sense, I am still like a cultural historian, right? And it just happens to be that I think a lot of questions in like cultural history, particularly that involve technical media, one has to start going to these other domains to start explaining how, where a particular kind of representational norms in a telephone interface, a mobile phone interface, or a video game come from. And so part of what I'm interested in the Vermeer, right, is with the Vermeer, I'm trying to say, okay, actually, we can find some of these competing subject positions or irresolvable subject positions, this kind of confrontation of graphical, geometric, visual, pictorial things that are happening already. They're being registered in the so-called mainstream dominant traditions of, say, visual culture, right? In a weird way, like I'm sort of looking at that painting a little bit as if I was looking at a computer with windows. Like I'm just interested in like this interesting layering of modes that doesn't kind of and that doesn't kind of subordinate to one or another particular subject, but actually says vision implies different subjects, some that are individual, some that might be distributed and systematized, right? Because, right, and this is partly what Pablo's gesturing towards, a lot of my point of reference here is looking at like mid-20th century radar systems. And I'm interested in how the mid-20th century radar systems can oscillate between different forms of display, some that are wildly infographic, some that are pictures of maps, some that are meant to be pictorially read, some that are kind of numerically read. And so in this kind of layering of different types of visualization and this play between them, I'm looking for other precedents. And the Vermeer seems like a possible sort of possible, it's not a source, but a precedent. And then I think, I mean, that's the great thing about Moby Dick, in a way that's maybe complementary to the Vermeer. You know, somehow Herman Melville is able to wrap up the entire expanse of the world into a single story, so that he has thick, wild technical descriptions. He has all different types of environments, all different types of people, all different types of knowledge, all held together by a narrative. And I guess in some sense, I mean, what I feel like you're pointing towards, I don't know if this is what you mean to point towards, but you can tell, like, basically you can tell, like, I'm a barely reformed, like, Latourian actor network theorist. I'm interested in how all these different things of the world are tied together into networks, and how they're totally heterogeneous and yet they hold together. So the radar screen, the Vermeer, the Melville are this way of understanding how these things work together in a kind of strangely networked manner. And I kind of want to tell stories that, on the one hand, show these coexistences, but at the same time, you know, I guess I'm also trying, and maybe I haven't gotten there yet, with the description of the Sperry battle tracer. The Sperry battle tracer, I think, does offer, maybe I need to push deeper with it. There you have a kind of a more pure description of a particular type of observing subject, or really, to use Pablo's word that he asked about, an operator, a human operator, where computer graphics presume an operator as the ideal subject, right? It's not about perspective, but it's operations on series and patterns that are constantly flickering up visually so that the data can kind of keep circulating. And that, I think, is the kind of alternative mode, the alternative subjectification. But yeah, you're right. Without realizing it, I'm attracted to these formats that seem to mix the modes, like a novel or even a computer game. You know what I mean? I feel seen somehow. That's very interesting. I'm going to think more about that.
Oh, thank you. Any more questions? I mean, I kind of felt challenged by this question of you, Bernard, about the alternatives to the military history.
One other thing, I'm sorry, just one thing I just want to say. I don't want to ramble on forever. I think, in a way that I'm not going to explain now, John mentioned Weizmann. In a weird way, like, I'm interested in Weizmann because, okay, Weizmann approaches computational infrastructures as kind of like forensic databases.
Exactly.
Like, yeah. In a certain way, I think Weizmann is, in a way that's different but complementary to Feroki. Weizmann knows how to read the computational. And his analysis, I think, is totally at concert with the Seafaring mode of analysis, which is, again, constant data-driven amalgamation of information into a kind of loosely bound infrastructure to make sure you know what is where and how things happened. Do you know what I mean? So I think Weizmann knows the truth of computer graphics in a weird way. Sorry, I'll leave it there.
But that's also what I wanted to kind of draw on, because this whole idea of investigative aesthetics tied to forensic architecture, and I think architecture would be maybe another history, especially in the early modern. I thought about an article I just read about Raffaello Santi's letter to the Pope from 1518, where he described, where it's all about preserving, surveying, and mapping the ancient monuments of Rome. And he describes how he does it, like, kind of with orthogonal projections, which he kind of sees more scientific than the linear perspective, because, you know, it's reproducible and stuff. So maybe architecture since I was triggered by this question about the alternative to the military history. So maybe architecture would be one starting point to look at projections and kind of different ways or classifications as an alternative to logistics, maybe, or something. Just
I think that's true. I think architecture, and then there's the great Ziegert example, land surveying.
Yeah.
Yeah, I think that's really interesting. I never thought about, it's interesting to think about, maybe that's the secret of Weizmann. He belongs to a tradition of reading graphics that has unique traction when it comes to the computational or something. And it relates to architecture's peculiar relationship to graphics as well. Or as you mentioned at the beginning of your talk, maybe, I mean, on some level, I was really grateful to you trying to say, like, I'm trying to offer an alternative to computer-aided design and Xerox as being the source of computer graphics. But, you know, on some level, actually, all these histories kind of intertwine. And I think if I can tell this story adequately, I think fields like computer-aided design will actually be somehow working in concert. Do you know what I mean? They're part of a rich, varied fabric of, you know, graphical reasoning or something.
Okay, so we are running out of time. I see it's 2:30 already. I think we could go on and on, but maybe we continue in some other place, some other time. Thank you from my part again to you.
Thank you, Pablo. Thank you everyone for your questions.
Thank you very much. Cornelia, you want to say
Yeah,
something about the next?
just maybe one final sentence. I want to thank you all again for, also in behalf of the Center for Geomedia Studies, of course, for your participation. It was really interesting, thoughtful, insightful, and inspiring, of course. Yeah, and I hope I see you again at our next Geomedia Speaker Series event, maybe here in Karlstad. Yeah.
Great.
Okay.
Thanks for
Thank
joining.
you, everyone. This is really exciting.
Hello.